Hello once again, class, and welcome to another mock lecture. Today we're going to be tackling three basic data visualizations, starting with pie charts, moving to bar charts, and then talking about histograms. The first two are ways to visualize categorical data. The second way is to visualize quantitative data, right? Remember the differences, if you're taking a survey and your answers are like categories, like favorite colors, that's categorical data. You'd want to use a bar chart or a pie chart for that. Histograms do quantitative data being like surveys that ask, how many hours on average do you exercise, right? Your answer will be a number of hours, the average for which would make sense. That's quantitative, that's numerical value stuff. Okay, we're going to start with categorical data, beginning with pie charts. All right, so here's a pie chart. I gave this a little bit of data visualization flair, right? So there's some little blurbs about it's eye-catching. In general, you want your data visualization to tell a story, and that's what I'm trying to do here. But anyway, this is a pie chart. There's 5 slices. The thing about a pie chart is it's a visualizing area. So it's what portion of the whole does each category take up? And so it's a way to compare sizes of categories, right? Number of votes in this particular example. The biggest area received the most votes. The smallest area, smallest slice received the least amount of votes. So it's fairly intuitive. It's an intuitive representation of the data. Of course, we've got the legend over here that's telling you what color matches to what slice each of them is. And in fact, I should even say, and I didn't draw an example of this, but sometimes you have a legend like this, and other times you have like the name of the category listed on each slice of the pie. But sometimes you have the actual numerical value listed in each slice, so you can compare directly how the number of votes each category received in this data visualization. Other times you'll have percentages, which is kind of nice because then you get to you don't have to guess, right? Even though you could probably say, hey, this is like somewhere around 45 to 50%. I mean, it's less than 50 for sure. But here they're just telling you it's 45%. Constructing these without technology is insanely annoying. Like you have to know that the full rotation is 360 degrees. So if you want to find how many degrees each slice is, then you'd have to multiply their percentage by 360. In this case, I did that. So then I'd have to use a protractor, draw a straight line, draw a radius here, and then measure with my protractor 93.6 degrees, and then draw another one, right? And okay, there's my portion of Super Smash Melee in this case. Then I got to do that for 64 and Brawl and Smash 4 and Smash Ultimate. So you get all of these things, and then finally you've created your pie chart. In today's day and age, nobody does that. Nobody's going to go and draw a pie chart. Instead, they'll type all their information on Excel, and then they'll just use Excel or some other program like Excel to create a data visualization of the data that they're looking at. So here's some things about pie charts. First, they're used to display categorical data. They can help visualize how much of the whole each category is. So like I was saying, the area of each one of them is proportional to how many votes that category received. And they can help compare other categories to one another, right? So you can say visually, Smash 4 and Smash 64 received, kind of the same amount of votes, based on area. And in general, I think a pie chart is a terrible way to represent data. In fact, there is another data visualization that is better than a pie chart, in my opinion, literally every way. And it's a bar chart. This is a bar chart, okay? This is the same exact values that we were using before. Same data that I'm using to create both the pie chart and the bar chart here. So we've got a legend. Some things about the bar chart to notice is that we've got a y-axis in this case that's telling you the number of votes. So we have a nice scale here. The x-axis is going to be our categories. Again, I'm choosing to do that with legends. And then the other thing that's important about bar charts to know is that the bars, each individual bar for each category, don't touch each other. The reason I'm pointing this out is because when we talk about histograms, the bars do touch each other, but these are all, disjoint categories. They're all separate categories, and so we want to illustrate that with the data visualization by showing separation between all the bars. The categories are distinct. Sometimes you'll see bar charts that have these numbers here. This is my personal favorite way to represent data with a bar chart. I like to have the number there. That way I'm not kind of guessing like, it's a little less than 300, so it's probably like 286. I like to have the number there. But you can clean it up a little bit by getting rid of those numbers on the top. You can even get rid of the legend and just put the category name underneath each bar here, and that looks pretty clean. Just pretend my handwriting looks nicer. But in my argument is that a bar chart does everything that a pie chart can do, except better. Bar charts also are used for categorical data. They can be oriented vertically or horizontally for a little bit more eye catchability, if you will. Horizontal bar charts are pretty cool. It's better than a pie chart in virtually every single way. And to illustrate that, let's consider this data. All right, this is a list of Final Fantasy VII characters, which is the best game ever created. And let's say that some amount of people were asked who their favorite character was. It's a popularity poll for Final Fantasy VII characters. If you want to illustrate this data with a pie chart, it's going to look like this, which is, how do you even read? Just looking at this, there's so much information that you have to sift through to figure out which one is the best character, right? Which character won the popularity poll based off of this? Probably in a situation like this, what you would do instead is you would put the name of the character and then in parentheses their overall value. But this was just the default pie chart that Excel spit out to me. They had a legend here, and then, which is just awful. You have to tell, here's the thing, even if you put a name here, this is still a lot to look at. Some slices you can barely even see. And so in my opinion, it's just not a great way. I can't even compare things when it looks like this. I see some things of similar size, but there's just too much going on for me to decipher what's actually happening here. A much more simple and direct way to compare which character was most popular would be a bar chart. This is significantly easier to look at. Even if I did have a legend where each bar was a different color, that still would be annoying. So I'm definitely being a little unfair because this legend here is just awful, and I probably should have made it so that the names were here. But still, my point stands. It's still hard to compare relative sizes of things when in something that looks like this. But here it's very easy to tell, right? I can immediately see the high bars and the low bars and see who that is. And there's a nice scale that looks very clean. It's kind of minimalistic. Granted, this is a bit hyperbole. It's almost worst case scenario for pie chart. And I'm doing this just to really show the stark differences in the way information can be portrayed, right, between these two things. But let's go back to this basic example, because at least in this one, the pie chart here isn't terrible, right? It's definitely not like the last example. There's only 5 categories and it's relatively easy to read. And you might even say, Mark, I see what you're saying, but I still like pie charts for when there's not a ton of categories because it's really easy to see what portion of the whole each category is. These percentages specifically are more, you're able to intuit them more than you would with a bar chart, because with the bar chart, you can't see the whole, right? There is no whole to compare each bar to. And to that, I would say, well, then just add another axis, right? The cool thing about bar charts is that you could have a second y-axis that's measuring something different. So in this case, I'm measuring number of votes. That's the standard axis. That's this one. But then I have this other axis that represents the percentage of the whole, right? The percentage of the votes. And you can see it's 45%, right, for Smash Brothers Ultimate. So same information can be displayed as the pie chart does. And so in this case, the bar chart can be a little bit more versatile and still easy to compare every single category. Okay, now you might say, well, what if there's only 3 categories? What if your whole point is to really put forth the idea that each category is virtually the same in size, everything's equal, no category is more important than the other one, even though there might be some minute percentage differences, which I'll show you here in a second. But if my whole point is to show that each category is roughly equal, isn't a pie chart the best way to go? And I would say, a bar chart can also do that, right? They're all about the same height. So you could say the same thing. And furthermore, I know what I did is I put on the percentages here to kind of belabor my point a little bit, but I can see now visually which one's the highest one without having a percentage bar right on the side here. So I don't have a second axis on this one to show you what percent of the whole, right, it is. But I also don't need it. They're all roughly the same percentage, but I can visually tell this bar is the highest one. But okay, I will stop talking about. You could argue in this case, maybe a pie chart is fine. I still think the bar chart is doing the same thing as the pie chart here, but better. But okay, we can stop. I'll stop harping on the pie chart. We can move on to something else. Although just one more thing here, actually. Let's go back to this, because if you really think
2 hours later.
Okay, when you have two categories, like a yes or no poll, okay, these tie. They can tie in this one specific situation. I will concede that a pie chart is as good as a bar chart. But I would still go with the bar chart. Now you might be sitting there thinking, Mock, why are you talking so much about hating on the pie chart, right? If you don't want to use pie charts, then don't teach us about pie charts. Just teach us about the bar chart. And I wish I could do that. But here's the thing. Pie charts are out there, right? They exist out in the wild. And we need to know how to read them. People still use pie charts. Not you guys, right? You guys are welcome to bar chart subscription land, right? You guys are going to do the bar chart stuff. I believe in you and I have faith. But there are people, right, that use the pie chart. And so we need to know how to read them and interpret their information. Okay, I'm actually done now. Let's talk about quantitative data. Histograms. Histograms are the only data visualization in this video that pertain to quantitative data. And here's what it looks like. And I think right away you're going to notice some similarities with bar charts, but they are different. Okay, they're very different. I mean, aside from the fact that now we're talking about numerical data values as opposed to categorical data values, the bars are touching. Maybe that's the first thing to point out here. If you're looking at a quote-unquote bar graph and the bars are touching, it's a histogram. So it's talking about quantitative data. If they're not touching, it's categorical data. Just right away, you get that kind of for free. Let me talk about this example first. Let's pretend we're a teacher. We had a class of 30 take a midterm. This is how their scores were distributed. So this bar represents all the scores that were between 30% and 40%. These are the scores between 40% and 50%. These are the scores between 50 and 60. Here's the D's. Here's the C's. Here's the B's. Here's the A's. Right? That's kind of how I'm looking at this. Here's the frequency, right, of each of those scores in this data range. So this represents a data range. Anything from 30 to 39, this is how many scores there were of that, right? According to the graph, it looks like there was one score that this student was clearly not ready for the exam. In fact, all of these students clearly not ready for the exam. But okay, so bars are touching. That's the first thing. The width of the bar is called the bin width. And they're all exactly the same. They're constant, right? So this represents 30 to 39. That's this bin. Then this bin is 40 to 49. This bin is 50 to 59, 60 to 69, 70 to 79, right? So on and so forth. Bin widths have to be constant for the histogram to make any sense. You want to keep bin widths constant. Okay. I put the x-axis down here as just the continuous numerical values. And by the way, the fact that they are continuous numerical values, it's basically kind of a normal x-axis. That's the reason why the bars are touching and not separated. Right after a score of 39 comes a score of 40, and so that's why the bars are touching. There is an alternative way to label the x-axis though, and it would be the actual bins themselves. So this is any score between 0 and 9, score between 10 and 19, 20 and 29, right? 80, 89. These are all the bins themselves. And any scores that fit inside of a bin, you're going to count as one more on the frequency scale. So if you have a score of 82 and 83, that counts as a +2 frequency for this bar. Right. So according to this, in this class, we had about 8. We had 8 students record a score between 80 and 89. 8 B's out of 30. It's not bad. So let's say here's the data that I used to make this histogram. Okay. Let's just go through this kind of bar by bar. In this example, the bin width is 10. There's nothing between 0 and 9, between 10 and 19, and between 20 and 29. So that's why there's no frequency, right? You can almost say the bars are here, right? I don't know why that's doing that, but you could say the bars are like right here. And then the histogram starts. But okay, the reason why we start here is because there's a score of 34. Okay, so the frequency is 1. So the bar, that's actually it. That's the only score between 30 and 39 is 34. So the bar has a frequency of 1. The number of exams between score 30 and 39 is 1. So the height of that bar is 1. Okay, then we move to the next one. The number of scores between 40 and 49 is 2 of them. There's a score of 42 and 46, so we put the frequency up to 2 for that. The next one has 3. Scores between 50 and 59, there's 3 of them. All right, so the frequency for that bar is 3. The next one looks like it's 5. There's 5 Ds in this case, the frequency of 5 there. You move on to the Cs, there's 9 of them. You move up to the Bs, the bin that has scores between 80 and 89, there's 8 of those. So there's 8 Bs. And then finally, there's 2 As, 2 scores in the 90s, right? And that's how we created this graph. What we could do for another example is, let's say we want to change the bin width to 5. Let's see how scores are distributed if we change the bin width to 5. So we'll start at the beginning, and I'll just point out that the only thing that I did so far is I changed the scale here. So there's a bunch of between values. So this is 5. That means that this is the bin 0 through 4. This is the bin 5 through 9. This is the bin 10 through 14. This is the bin 15 through 19, right? So on and so forth is how we're going to do that. Each of them has a width of 5. So to help me plot this better, I'm not going to just count up everything and go one at a time. Let's make ourselves a nice table of values for the frequency of each of these bins. So I'm going to put the first, 6 bins on here because there's nothing in them. So just to kind of show you how this goes, you'll notice that there's no overlap in the bins and each of them has a width of 5, right? 0, 1, 2, 3, 4, that's 5 numbers, right? 5, 6, 7, 8, 9, that's 5 numbers. And there's no overlap between the bins. So a score would not be able to fit in 2 different bins. It's always just in 1. But anyway, there's no scores of any of this stuff. So the frequency is 0. So we're going to have nothing for the first part of our graph, just like the other one. Where things start, though, is there is a score between 30 and 34. There's 1 of them. So I put the frequency as 1. There's nothing between 35 and 39. So frequency there is for that bar is going to be 0. There's 1 score between 40 and 44. It's the 42. There's 1 score between 45 and 49. It's the 46. Nothing between 50 and 54. And then I'll just fill out the rest here. 3 between 55 and 59, and here's all the rest of them, and here's all the frequencies. Okay, you can check this if you want. You can pause the video to make sure that I did everything correctly, but it should all be accounted for here. So I've just found the bins, labeled the bins, and I've got my frequencies. These are the heights of the bars that we're going to see in our histogram. Okay, so I'm going to get rid of this thing and just move the table of values over to the right-hand side, and this is how I'm going to graph this thing. So first thing I'm going to do is start off with the bin 30 to 34. The height of that bar is 1. The height of the next bin is 0. The height of the next bar is going to be 1 and then 1 again. Height of the next one 0. And then I just continue to fill this thing out, right? Different heights of the bars until we're done, right? This is what the histogram would look like with a bin width of 5, which is slightly different, right? In fact, if I overlay the previous one on there, you'll notice that it's significantly less high and the distribution looks a little bit differently. I would argue that the better one is the one with the bin width of 10 because letter grades are a thing in academia. Whereas I'm not sure if it's that important to see, here's the C minuses versus the C and C pluses. But that's effectively what the bin width of 5 is accomplishing, is it's breaking things down even more. But I'm a personal fan of the bin width of 10 model, and you can see the distribution of A's and B's, I think, more accurately with that sort of model. But that's how you would make histograms, okay? There's a lot more things that we could talk about with histograms, like the distribution of the data. We could talk about the different measures of center, and we're going to talk about that. But I think for this video, I just want to keep it as here's ways that you can visualize some data when it's categorical. Here's ways you can visualize some data when it's quantitative. So we'll stop there for now. All right. So hopefully you guys learned something. Hopefully you understand bar charts are always going to be superior to pie charts. If you have any questions, please drop a comment below or send me an email. Thanks a ton for watching, and I'll see you in the next one.